Here we're asked to solve 3 tangent x over 2 plus 3 equals 0. And they don't say anything else to us. So we have to assume that the domain is this negative infinity to infinity, all real numbers. You know me, if I don't just have an x or a theta or an alpha or a beta or whatever, one single angle here, I say let theta equal x over 2 because I want to solve an easier problem. I don't want to work too hard. And so this will allow me to solve this problem. I've substituted theta for x over 2. Why? Because that wasn't simply a single angle. It was 1/2 x, or x over 2. So now I'll solve for theta. Subtract 3 from both sides. 3 tangent of theta equals -3. Divide both sides by 3. Tangent of theta equals -1. All right? So I go to my unit circle and I say, all students take calculus. Tangent of an angle is a ratio. The ratio here is negative. Tangent is positive at A and T and negative here and here. So I have a second quadrant angle and a fourth quadrant angle. Notice the angle that I'm looking for is here and all the way to here. Those are the unknowns. That's what theta is. All right. So remember, they've given us a ratio. Now, just one little factor here. Once I have my terminal side of the angle, remember, the initial side of the angle is that positive x-axis. I'm going to make a triangle. I go from here, this point on the unit circle, down to include the x-axis in my triangle. And I go from here up to include the x-axis in my triangle. Now, I know that this ratio here for tangent is opposite over adjacent. That's SOHCAHTOA, by the way. So this has to be positive √2 over 2 and negative √2 over 2 and 1 here. And this has to be positive √2 over 2 and negative √2 over 2 and 1 here, which forces our reference angles to be pi over 4 and pi over 4. So here I'm going almost all the way to 1 pi, which is 4 pi over 4, but I'm back it up, 1 pi over 4. So theta is equal to 3 of these pi's over 4 plus 2 pi n. Now, I could say theta is equal to 3 pi over 4 plus pi n. Do you see that these are directly across from each other? So I could say plus 1 pi n instead of listing 3 pi over 4 plus 2 pi n, and theta is equal to almost to 8 pi over 4, but back it up, 1 pi over 4, 7 pi over 4 plus 2 pi n. I come up with this one general solution because I want to be more efficient. Now, if you want to do it twice, be my guest, but then you'll have to tag on plus 2 pi n to each of them. But I chose this solution, and I see that they're directly across from each other. So to get from one solution to the other, I'm going to have to add pi n. By the way, n is an element of the integers, and we know that that's -3, -2, -1, 0, 1, 2, 3, etc., in both directions forever and ever. All right? I didn't want theta, though, did I? I'm going to resubstitute. Here is the key statement. Let theta equal x over 2. So now that I've solved for theta, x over 2 is equal to 3 pi over 4 plus pi n. Now, how do I get rid of divided by 2? Multiply each and every term times 2. So I'm going to have 2 times 3 pi over 4 plus 2 times pi n. Don't forget to do that to both. So x is equal to, in the end, x is equal to, well, 2 goes into that. 2 goes in twice. So this is 3 pi over 2 plus 2 pi n, where n is an integer. And that would be the most efficient general solution there. Note, usually I have y equals 3 tangent x over 2 plus 3. If I graph y equals 3 tangent x over 2 plus 3, and then I recognize, well, I don't have y. I've put a 0 in for y, which means we're trying to find x-intercepts. Notice, look at this x-intercept. It's x is equal to 3 pi over 2. And we said plus 2 pi n. So if we put in a negative 1 for n, that'll be minus 2 pi, which gives us negative pi over 2. So you can see graphically, we are getting all of these solutions. Now, I just looked at from negative 2 pi to positive 2 pi. But of course, there's infinite, that's negative 2 pi. There's infinite x-intercepts for this graph.